Hey guys, we're starting some stoichiometry now. So in slide number 56 in the example of stoichiometric conversion, we're given that two molecules of hydrogen, or 2 moles of hydrogen, will combine with 1 molecule, or 1 mole of oxygen, to form 2 molecules, or 2 moles, of water. So it's a 2 to 1 to 2 ratio. Using the reaction shown above, we're asked to determine the number of moles of water produced when 1.57 moles of hydrogen reacts with excess oxygen, meaning more than enough oxygen, whereby all of this hydrogen will be consumed in the process. When doing a stoichiometric calculation, always list what you know. In this case, we know there's 1.57 moles of hydrogen. Now, we're asked to solve for the number of moles of water. That's what we're solving for. So if we're solving for moles of water from moles of hydrogen gas, we need to know the equality. Wait a minute. 2 moles of water are formed for every 2 moles of hydrogen consumed. That's a 2 to 2 or 1 to 1 ratio. Now, because we use the equality that is in our balanced equation, and we simplify it to 1 over 1, we also look to reduce the unit moles hydrogen. 1.57 times 1 over 1 is 1.57 moles of H2O. So this is called the mole ratio step. It's not always 1 to 1. So make sure that you follow this format all the time. Our next question was, how many moles of oxygen and hydrogen are required to produce 3.58 moles of water? So 3.58 moles of H2O. That's what we're given. We're asked to solve for moles of oxygen from moles of water. In our balanced equation, 1 mole of oxygen is consumed for every 2 moles of water, which is to say 1 mole of oxygen was consumed for every 2 moles of water. Our units cancel. We get 1.79 moles of O2. We're also asked to solve for moles of hydrogen. So if we're solving for moles of hydrogen from moles of water, we look in our balanced equation to get our 2 to 2 ratio, which can simplify to 1 to 1. Therefore, in order for us to produce 3.58 moles of oxygen, we're going to need to combine 1.79 moles of oxygen with 3.58 moles of hydrogen. That's how much oxygen and hydrogen would be consumed to create exactly 3.58 moles of water. And that is the stoichiometry mole ratio step.